So indicator one now are dividing integers, and this is the fourth lesson that we are covering in indicator one. We've already done addition, subtraction, multiplication, and now we are going into division. So our learning target is I can use a related multiplication sentence to divide integers. We know that multiplication is the inverse operation of division. So just like addition was the inverse of subtraction, multiplication is the inverse of division. And so we are going to use a related multiplication sentence also to divide integers. All right. The biggest rule to remember when we have integers with the same sign or with different signs. The quotient of two integers with the same sign is positive. Okay, and the quotient of two integers with different signs is going to be negative. So let me just use the first two examples over here, and then I'm going to use with different signs, just using exactly these same numbers. Okay, so once again, quotient with the same sign is going to be positive. All right, so let's look at this. This is 18. That means it's positive 18 divided by positive 6. So since both are positive numbers, my quotient in this case is going to be positive. And quotient is nothing but the answer to a division problem. Okay. So 18 divided by 6, as you can see, both are positive. I'm going to get a positive quotient. So 18 divided by 6 is going to be 3. All right, when I talk about multiplication sentence, all I look at is the opposite or the inverse of division, and the inverse of division is multiplication. So all I can say is 3 times what is going to give me 18. So I know that 3 times 6 is going to give me 18, and that's how I just confirm that multiplication sentence is being used to divide the integers also. Okay, but now let's go ahead with the same signs. Now negative 18 divided by negative 6. Once again, both of these are the same signs. So when I do negative 18 divided by negative 6, I am going to end up with my quotient of 3. It's going to be positive. All right. Now, when I say different signs, this is what it means. If I say negative 18 divided by 6, now I have a negative sign here, and there's no sign here, which means it's positive. Okay, so a negative divided by positive, I am going to get a negative quotient. So this is negative 3. Same thing if I had a positive 18 divided by negative 6. All right, again I have opposite signs, so my quotient would be negative 3 in this case also. So that's a simple rule. Same signs, you get a positive quotient. Opposite signs, you are going to get a negative quotient. All right, so let's use the next example with the same sign. And if I say negative 48 divided by negative 6, as I can see, both have the same sign, and I know that 48 divided by 6 is going to give me an 8. So negative 48 divided by negative 6 is going to give me 8, which is a positive quotient, as you can see. All right. So if I divide negative 30 by negative 6, once again, I have exactly the same quotient, the same sign. This is negative divided by negative. I know that the multiplication inverse is 6 times 5 gives me 30. So on division, it's going to be negative 30 divided by negative 6. Same signs. I'm going to get my answer or my quotient as a positive answer. Okay. let's say I do negative 84 divided by negative 12, another example. So once again, both of these have the same sign. And I know that 12 times 7 gives me 84 because that is the division inverse, which is multiplication. All right. So negative divided by negative is going to be positive, and negative 84 divided by negative 12 gives me 7. So these are all my quotients. As you can see, all of them, when I have the same sign, my quotient is going to be positive. All right. So um, let's do a problem in which I am going to evaluate using algebraic expressions. All right. And I'm going to divide integers using the same sign right now. So let me just erase this part. And if I say what is evaluate, if I say evaluate y divided by x, please remember the fraction sign also means division. If y is equal to negative 155 and x is equal to negative 5. All right, and x is equal to negative 5. All right, so in this case, as you can see, that we have exactly the same signs, which is negative and negative. Y, we're just going to substitute the values now. So y is negative 155 divided by x, which is equal to negative 5. All right. And I know by looking at this that negative and negative is going to give me a positive quotient. I know that 5 times 3 is 15 and 5 times 1 is 5. So that means I am doing the opposite of multiplication of division, which is multiplication, in order to simplify. Or I can divide, and I can do 155 divided by 5. As you can see, 3 times 5 is 15, and I get this. And then 1 times 5 is going to be 5. So as you can see, here is my quotient, which is going to be a positive quotient because those signs are exactly the same. All right. Let's do another problem. Let's say I give you evaluate y divided by x. So same. If y is equal to, again, I'm using the same sign so that you can see, is equal to negative 162 and x is equal to negative 6. So now I am again substituting the values, and it says y over x. So negative 162 divided by negative 6. All right. Again, I know that it's going to be a positive response, but I know that 2 times 6 is 12. I get 4, bring this down. And then 7 times 6 is going to be 42. All right. So my quotient is going to be a positive integer. All right. Because again, the signs are exactly the same. Let's go ahead and do one in which I have opposite signs, so different signs. So if I give you a question where, let's say I have 90 divided, remember in different signs, first and foremost, we have opposite signs gives me a negative quotient, okay? So if I say 90 divided by negative 10, all right? So as you can see, the signs of the integers are different. This is positive, this is negative. So therefore, my quotient is going to be a negative answer. And I know that 10 times 9 is going to be 90. So 90 divided by 10 is 9. And the quotient is negative because they are different. So my quotient is going to be negative 9. Okay. Um, let's do another one with different signs. And if I do 72 divided by, let's do divided by negative 9. All right. Once again, as you can see that the signs are opposite. And if I use the multiplication inverse or sentence to divide the integer, I know that 9 times 8 is 72, right? So therefore 72 divided by 9, remember opposite signs, so negative, and this is going to be 8. And so this is the quotient with the signs being absolutely different. Okay. So if I have different signs, I'm going to have a different quotient. All right. So let's do another problem in which we are trying to solve an expression. And go ahead and divide. All right, so let's say I give you, we need to solve for x divided by 2y, and it's telling me that x is equal to 8 and y is equal to negative 4. Okay, so now what I'm going to do is I am going to substitute the values. Okay, I'm going to substitute the values. And instead of x, we know that x is 8. So I'm going to write 8. I know that y is negative 4. So I'm going to substitute the value. 2y means 2 times y. So that's going to be 2 times negative 4 because that's what y is. All right. And so I have this is equal to 8, and 2, that's positive times negative, is going to give me a negative product. And 2 times 4 is 8. All right. So this basically means 8 divided by negative 8. Either you can write it like that or you can write it like this. As you can see that the signs are different. So we are going to get the quotient as negative 1. All right, because 8 divided by 8 is 1. And then of course, because they're opposite signs, my quotient is going to be negative. All right, so let's solve another one using the different signs. We give an algebraic expression, and x and y are going to have exactly the same value like I put earlier. But let's now do negative x squared, and you can do plus 12 divided by y. Okay, so in this we are going to substitute the values of this that we had earlier. It's saying x is 8, so this is negative. All right, and x is 8, so therefore this is 8 squared plus 12 divided by y, which is negative 4. Which is negative 4. So if we follow PEMDAS order of operations, please excuse my dear Aunt Sally. We know that exponent comes first. All right. And 8 times 8 is 64. And I have the negative sign in the front. So this becomes negative 64. All right. Plus 12 divided by negative 4. All right. Based on order of operations, we are going to now divide 12 by negative 4. Please don't add first because that goes against the order of operations. Okay. So this will be negative 64. And we are dividing the opposite sign. So we are going to get a negative quotient. So 12 divided by 4 is 3. But because they're opposite signs, this is going to be -3. All right. So now we have -64, and we are adding on another of 3 negatives to it. Okay. So because they are same signs, these two we are going to add, and I get -67 as my answer to this problem. So the value of that expression is -67. All right. So it doesn't matter, when you're doing division, it has the same rules as multiplication. That basically same signs is going to have the positive quotient, and opposite signs is going to give me a negative quotient. All right. Um, well, one last thing I did want to do is, let's see. I just want to show you this one, like how to use the multiplication, because we know that division is the inverse operation of multiplication. The same way that subtraction is the inverse of addition, you can find a quotient by using a related multiplication sentence. So let's go ahead and do this one. Um, all right. So let's say I give you 36 divided by -3. All right. So if I look at 36 divided by -3, uh, all I can do is this. I know these are positive. This is positive. This is negative. So opposite signs, I am going to get a negative quotient in this case, and I get -12. Okay, I get -12 because they have different signs. All right. So when I'm looking at the multiplication sentence, okay, basically I'm thinking of what number multiplied, because remember multiplication is the opposite, by -3 results in 36. All right, in 36. So this is how we are using a multiplication sentence. What number multiplied by -3 results in 36? And so when I look at this, I know that the quotient of two integers with different signs is going to be negative, right? And so all in this case, all I'm doing, and then if I multiply something with the same signs, it is going to be positive, because multiplication division have the same rules. So if I look at this, I have what number multiplied by -3 results in 36. So if I'm using a multiplication sentence, -3 times -12, and I know the negative times negative is going to give me positive, gives me 36. All right. So this is what this part of the learning target is. We know once again that division is the inverse operation of multiplication, and you can find a quotient by using a related multiplication sentence. So that is it for indicator one. Once again, the rule: same signs, you will get a positive quotient, and opposite signs, you are going to get a negative quotient. All right. Have a great day, y'all.